Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is the specimen paper for 9231 Further Pure Mathematics 1 for the 2020 exam series, question 6b. We've worked through A, the requirement for B, find the shortest distance of D from the line through A and C. To begin, as a reminder, the value of M in the main question we confirmed in part A is 2. Visually, what we're working on in B is if we draw a vector from A to C, here not reflecting accurately what the direction vector is, but just giving an idea with a diagram. If we want to know the shortest distance to point D, what we're looking for is a perpendicular from AC to point D. In order to find that distance, I'm going to go through 3 steps. 1, I want to find the unit vector in the direction of AC. 2, I want to find AD. And 3, I'm going to calculate the magnitude of vector AD and the cross product of the unit vector. For 1, I'll begin by finding the direction vector of AC. I'll have an I value, a J value, a K value. AC will be C minus A, looking at the I coefficients for C and A, 1 minus 2. Then for J for C and A, 4 minus 4. And for K, 1 minus negative 3. I have negative 1i, negative I. 0 is the J coefficient, there's no J component, plus 4k. For the unit vector, I'm going to take the value 1 over the magnitude of the I, J, and K values. We have negative 1 squared plus 4 squared, and multiply by negative I plus 4k. This is the unit vector in direction AC. For 2, calculating AD, going from D to A, we'll have an I, a J, and a K component. D minus A, the I values 1 minus 2. The J values 5 minus 4, and the K values 2 minus negative 3. Simplifying to negative I plus J plus 5k. For step 3, I'm going to set up a vector product calculation. I, J, K. I'm going to keep the unit vector adjustment, the 1 over the square root of 17, which is what our unit vector factor simplifies to the last line of step 1. I'll keep that outside. And looking at the I, J, and K components of AC, negative 1, 0, and 4. Then AD, negative 1, 1, and 5. Let me note at the top of the vector product calculation, plus I minus J plus K, a reminder to multiply the minor determinant for J by negative 1. I end up with 1 over root 17 times the column matrix, negative 4, 1, and negative 1, which multiplies out to 1 over root 17 times the square root of negative 4 squared plus 1 squared plus negative 1 squared, which equals 1.03. This is the shortest distance of D from the line through A and C. This completes the requirements for Part B.